Take a look at this large, traditional clay water pot, known as an ensuwa. If you pour a cup of water from an ensuwa on a blistering hot Ugandan afternoon, you will find it surprisingly cold and refreshing. You cannot build a vessel out of normal dirt. Ordinary red topsoil from a school compound simply crumbles if you try to bend it. But true clay has a physical property called plasticity. Its microscopic, flat particles slide over each other when wet, allowing the material to bend and stretch without breaking. To find material with this level of plasticity, you have to leave the dry compound and harvest directly from local wetlands, swamps, or riverbeds, where dense, waterlogged earth naturally accumulates. Turning raw earth from a swamp into a functional water cooler is an exercise in engineering. Success depends on how you manage geological materials and solve structural problems with your own hands. This X-ray view of freshly harvested clay shows our first problem. Raw earth is full of small stones, roots, and twigs. You must manually extract all of these impurities before you begin shaping. If you skip that step, the heat of the firing process will turn those tiny impurities into a severe hazard. Trapped air bubbles and residual moisture locked around stones act like small bombs. When the clay gets incredibly hot, the trapped air starts to expand, causing the entire pot to shatter from the inside out. We solve this through wedging or kneading. By repeatedly pressing and folding the clay, you manually compress the material. This physically forces the trapped air out and creates a uniform, dense consistency. Kneading is a strict engineering requirement. Without this dense, uniform consistency, the pot cannot survive the extreme temperatures of the fire. Once the material is safe to use, you have to choose your geometry. This diagram illustrates the pinch method. You start with a sphere, push a thumb into the center, and slowly thin the walls by pinching and rotating. It is incredibly fast and perfect for making small items like an ikebia, a local serving bowl. However, you cannot pinch a massive ensuwa. If you try to stretch a single lump of clay into a large water pot, the walls will become too thin to support their own weight, and the vessel will collapse. To build vertically, you need an architectural approach, the coil method. Here, you start with a thick, flat base and build the walls upward by stacking and layering long ropes of clay. But consider a structural problem. What prevents these stacked rings of wet clay from simply drying out and peeling apart into separate pieces? You must chemically and mechanically bind them using the slip and score rule. You scratch or score the surface of the clay and apply slip, a liquid mixture of clay and water. The slip acts as a powerful glue, seeping into the scratches to lock the layers together. The scale of the vessel you want to build dictates the construction method you use, and the physical properties of the clay dictate exactly how those layers must be joined. A fully constructed pot is still incredibly vulnerable. If you place a sun-dried clay bowl outside and it begins to rain, the vessel will absorb the moisture, lose its structural integrity, and melt right back into mud. Firing makes the vessel waterproof. The intense heat of a kiln or fire pit transforms the clay's chemistry, locking the microscopic particles into a rock-hard state. This comparison table summarizes your construction options. The pinch method relies on a single ball of clay to rapidly create small, lightweight items. The coil method requires a slower, layer-by-layer approach, providing the structural support needed for tall, heavy vessels. Sourcing raw clay from a wetland, diffusing its structural flaws, and calculating the geometry of its walls requires a deep understanding of materials. By mastering these steps, you practice chemistry, engineering, and a powerful Ugandan tradition, all with your own hands.